Okay, so we're going to be doing question 704 binary search for LeetCode. So this question is implementing the technique binary search. So you maybe ask yourself, what is that, right? So binary search is based off the term divide and conquer, right? You are given an array here for the example, and you're given a target, and it's saying, okay, we want you to output the index of that target. And what you could do is do a for loop and iterate through every single number, right? And to be honest with you, in small cases, that's not that bad, right? But you have to think in the bigger picture, right? If we were doing that with millions of values within the nums array, that's going to take forever, right? And there's a way we could do that that cuts that amount of time that we need to do in half, and that's binary search, right? So the whole concept of binary searching is when you grab the length of your whatever you're searching through, in this instance, nums, right? And you divide it by 2. So when you divide it by 2, you're going to get a value somewhere in the middle, right? And you're going to compare that middle value and see if it's less than or greater than the target, right? If it's greater than the target, then we know that that value has to be somewhere on the right side, right? And because it's somewhere on the right side, then we already eliminated the entire of the left side, right? We don't need to traverse through that. And vice versa. If we're at the middle, let's say 5, right? And our target is less than 5, let's say it's 0. We know it's going to be to the left side. And we don't need to check this right side, so we just exit out, right? So now as we have an idea that, okay, binary searching is when you grab the number in the middle and compare it to the target. And if the target is less than the number we're on right now, then go back. And if it's greater than, we go right. So how are we going to go and actually write that in code? So the first thing we're going to do is we're going to create 2 pointers, right? We need to grab, you need to grab your left, you need to grab your right. So left is going to equal 0, and right is going to equal the length of whatever traversing. In order to get the length, you do the method len, and then within its argument, well, it's actually a function, the length function, and with aside the argument, you put nums, and we're going to do -1. So now this gives us the length, the total length, and our left is starting in the beginning, so we're going to set that equal to 0. And we want to basically traverse through this whole list. So in order to traverse through this whole list continuously and updating these values until we're finished, we use a while loop. We're always going to use while loops when working with 2 pointers. 2 pointers is when we have the beginning and the end, right? So how that while loop's going to look is while left is less than right. Um, so now as we have this while loop, right, we're able to kind of do all the code that we need to do inside of here. And the first thing we're going to do is grab that middle value, right? That's the first step that we mentioned. How do we grab that middle value? Well, first we need to make a variable, right? So we could have it, and we need to now calculate it. Now, how you would think, okay, well, we need to grab the length, right? And divide it by 2. So, yes, that's exactly what we're going to do. We're going to add left plus right, put these both in parentheses, and then divide it by 2. So, now as we have our mid, our variable, our middle number, right? Um, you maybe ask yourself, why are we adding the left and right instead of just having right? Well, we're going to be updating these left and right values. So because we're updating them, mid is also going to change as well. So we need to make sure that we use both of them, so we get a proper changes when we make those when we are checking those if conditions, which we're going to work on right now. So you have your 2 pointers left and right, you have your while loop, and you have your middle variable, right? Now we need to check if this number, if the number at index mid is less than or greater to our target. We'll start with less than, right? So if nums at index mid, if this is less than our target, right, then we are going to, if it's less than our target, we are going to move to the right, right? So we are going to do right, or actually we're going to do left plus or equal 1. And then we'll do else if nums at index mid is greater than the target, then we are going to do right minus equal 1. And if it is equal to the target, then we're just going to return mid, right? Beautiful. So this is checking if the number is less than, and then this is checking if the number is greater than, and then this is checking if the number we are on is equal to the target, right? So we basically have every single condition that needs to be met, right? If the number is less than, then we increase left by 1. If it's greater than, then we decrease right by 1. And if the number is equal, then we return mid because we found our answer, right? So let's say we're running through this loop and we have a condition here which says if your target exists, return the index. If not, or otherwise, return -1, right? So that's why it's really important to read these questions, because you will have test cases where it's not going to be so black and white. In this instance, we don't have an answer. And because we don't have an answer, we need to just return a value if none of these conditions are met, which you do that outside of the loop. So we're just going to return -1. So this while loop is going to run this whole highlighted section, till left is not less than right. And if it's not less than right, then we don't return anything and we just return -1. If it is, right, if we do have this else statement where the number is equal, then we just return mid. So if we give this a run, perfect, and it works. And let's give it a submit, make sure that all our test cases are met. Oh, that is not right. Um, do, 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 Huh. Nums at index 5 equals target. Let's check. Um, Oh, let's check one more time. There you go. Okay. We just didn't do the less than or equal to side. Okay, perfect. So yes, when doing the while loop, we do need less than or equal to make sure that we do stop at the right time. And everything is checked. We have our mid variable, which basically gets the middle value. These if statements kind of update the left and right within. So mid is always changing. We do have this, we do account for if we don't find the answer, just return -1. And yeah, so just some quick pointers to take away from this is we are using binary search. Remember, binary search is when you start in the middle and you move left or right depending on a certain condition. In this example, the condition is our target, right? So if the number in the middle is less than our target, then we want to move up. If the number in the middle is greater than our target, then we want to move down, right? And because of that, we're up in the downs, we're changing our mid value. If not, if we find our answer, then we just return mid. And if it's not mid, and if it's none of these, then we just return -1.